Finally, let's explore data visualization. This is the last section in this module, and in this section, we learn to visualize data using Python's plotting library, matplotlib. There are several plotting functions available within matplotlib. Among the all, we would actually focus on 4 of them. We would explore scatter plots, bar charts, line charts, and histograms. Now, this list is definitely not exhaustive, and there are several other important plots that need to be used in a normal data science exercise. A few important ones would be pie charts, area charts, violin plots, box plots, and probably a couple of others. In this section, we will restrict our focus on only these 4 and give you a strong foundation to explore the remaining on your own. I would highly recommend all of you to explore the remaining plotting functions that are available within Matplotlib. To get started, please start with scatterplot. We'll actually use a dummy dataset to get started with. So let's explore Spider. First, let's import the package. So we say import matplotlib.pyplot. There are 2 versions available. We have pylab as well as pyplot. I would highly recommend you to start with pyplot. We import this package as an object called plt, and now we also need numpy. So we import numpy as np. Numpy will give us a lot of functions that will help us create random numbers. To create a dummy dataset, let's create 2 random x and y variables. So x and y variables, let's say we create a variable with random 50 numbers somewhere between 100 to 500. So we can leverage the numpy's random library. So np x is equal to np dot random dot randint, and we will say a start point, let's say 100, and end point, let's say 500, and a number that we would need. So let's say we choose a sample of 50. So this function generates random 50 integers from 100 to 500. Now we can do the same for y. Let's say y can actually have a larger range. Now from 100 to 1000, we generate any random 50 numbers. Let's execute them and see what kind of values we have in x and y. So in x, we have some values. I'm sure the range is definitely 50. In the same way, y also has some random values with a larger range. Now, since we have imported the pyplot object as plt, we can use the plt scatter function to build a scatter plot. So let's say plt scatter, and we provide the x and y variables x and y. Now, if you plot this, we get a plot which is not so visually appealing. Yes, this is definitely random numbers. We have random x and random y, and you can as you can see, x is actually ranging from 100 to 500 and y is ranging from 100 to 1000. So what is missing in this scatter plot? On the cosmetic front, we have x-axis labels, y-axis labels, the chart title. These are the first things that will come to your mind. Let's use the internal functions to add these elements. So let's say we add a title. So plt.title, we add a normal chart title. This is a sample scatter plot. Alright, this looks good. And then we say plt.show because we have invoked several parameters. Let's execute this, and there we go. This looks good. We have a title now. What about the x-axis labels and the y-axis labels? Let's add them too. So plt.xLabels, there we have it. Let's put an x-axis label. Now this is definitely a random one, so we put any label over here. The same goes with y. We put a y-axis label, which would be a y label. Just to test the cosmetic elements, now we do the code and rerun it. So we have an x-axis label, we have a y-axis label, and we have a title. In some scenarios, we would want to change the color of these elements or the kind of style of markers. These elements can be tweaked within the scatter function. So let's say I add marker as a triangle. A triangle is represented as a caret in Python. So let's add the caret symbol over here and let us run it once again. Now we can expect the markers as triangles. What if we want to change the color? Let's add a color element too. So we say the color is inside the bracket, we add color as, let's say, red, and we can execute the code once again. There we go. We have the cosmetic elements updated. There are a couple of different scenarios. We'll actually have a combination of two different elements inside a scatter plot. How would that look like? So let's say we have a scatter plot of x and y has two elements. It could be boys and girls. And now we need the boys plotted as a triangle, girls plotted as probably just a square. Let's try that. Let's try just a square as S and plot it out. Yes, that's successful. If we have two different elements, let's create an additional y. Now since this is random, I'm sure we'll have a lot of variation over here. So we'll just execute the same code again. Now y and y1, both of them ideally would have different values. Now instead of writing the same code again, I'm just copying over here. I'm saying on the same x-axis a different y, and I'm saying a marker as, let's say, squares, or let's say take triangles, and we take color as blue. On the same chart, let's have a scatter plot for boys and girls. This is just hypothetical data. Here we go. Using scatter plots, we actually try to understand the strength between two variables. So generally, let's say, had there been some relationship between the x-axis element and the y-axis element, we could have seen some sort of trend. That is, as in when x increases, y also increases. So a trend would have been like this, a positive increment trend, or a negative increment trend, which means that x and y inversely proportional. Now since this is random data, we don't see any patterns over here. But then this is just a demonstration to show how do we invoke the scatterplot function available within Matplotlib. Similarly, we can invoke a couple of other functions. Now that we have a good amount of understanding of how to develop scatterplots, let's take a shot at bar plots. Now bar plots are usually used to study the strength between similarly associated variables. So for example, let's say you are trying to understand the marks you have scored in different subjects. So on x-axis, you'll actually print the subjects, and on y-axis, you'll print the marks you've scored. And looking at the bar charts, you can actually understand which subject are you the strongest with, and which subject are you the weakest with. You try to understand the strength of these variables which are related to each other. Let's mimic the same using a random data set. Again, let's create a random x and a random y. Now in this scenario, since we have a bar chart, a sample size of 50 might not be ideal. Let's take, let's say, around 10 different or 5 variables. So we create x as 5 variables. So we say np.arrange and we say 5. So this should create a list of 5 elements, an np array of 5 elements. Is that so? Yes, 0, 1, 2, 3, 4. These are 5 elements. And on the y-axis, let's create another random sample of 5 elements between the values 50 and 100. So I would say np.random int. I would give the starting point as 50, the ending point as 100, and the sample size is 5. And this will give me 5 random elements. Let's see the values once again. Yes, we have 5 random values corresponding to the 5 x-axis labels. Now to plot in Matplotlib, the x-axis labels first need to be indices. You can actually use the plt.bar function where you provide the x, the y, and then we can later on add the x-axis labels. First, let's just print a basic bar chart. So we have x ready, we have y ready, and we can do a simple plot show. How does it look like? Let's have a look. Here we go. So we have the x-axis labels as 0 to 4, y-axis between 0 to 100, and we have a random plot. Now these are actually, let's say this could be considered as subjects, and this is the marks scored in that particular subject. We can say that confidently, subject 3 we have the highest marks, and subject 0 we have the lowest marks. Let's replace these values in the x-axis with some actual values. Let's say we would add x list as a list of 5 alphabets. So I would say A, B, C, D, E. Now this function, and I'm saying list of A, B, C, D, E, what actually happens over here is it creates a list of 5 elements from this string. I'll just execute this part. I can see the terminal. It's created a list of 5 elements. And I'm passing this to xlist. So xlist is now holding a list of 5 character elements. Now to invoke the x-axis indices to reflect these list variables, we need to pass in these values to the appropriate parameters. Let's say we say plt.xlist, and we invoke the same indices to map to these list values. So the indices were actually x, and the corresponding values from them would be xlist. If we run this, what would actually happen would be the x-axis indices are now mapped to the list variables, and we have the actual values over here. Now, instead of actually just alphabets, what if we actually create more meaningful names? Now, this could be something like, let's say, English. Second would be math. Third would be history. Fourth would be science. And fifth would be geography. Let's try this. Now we have new labels with more meaningful names. How does it look like? As we can see, the names are actually reflected to the x-axis indices. Now similar to the scatter plot, let's add a couple of more visual elements. Let's add the x-axis label, y-axis label, and the overall chart title. Those elements can be added over here. Let's say plt.title. Since these are dummy numbers, I'll say marks scored by John, a random name. We need the x-axis label, so we would say plt.x label, and that would be subjects, and the y-axis would be the marks scored. That would be marks obtained or scored. Now if we rerun this, there we go. We have a visually appealing chart where we have the x-axis labels, y-axis labels, and the overall title along with meaningful x-axis labels. Is there anything else we can do? Probably we can change the color. That element could be added over here. So we say color is equal to red, and there we go. We have an updated version of a bar chart. That looks neat. Now in some cases, there would be need to actually plot a stacked bar chart. Now for example, if you're continuing on the same scenario, assume that John scored marks in the first semester and the second semester, and we need to showcase the marks obtained by him in a single bar chart. We will actually showcase that in a stacked bar chart. So the first part of the bar chart will be the first semester marks, and the second part of the bar chart will actually be the second semester marks. So for that, let's create additional y variable, which will be the new marks for this new semester. So since these are random numbers, I'm creating just y1, which will have a new set of values generated compared to y. So if you compare y1 and y1 has 51, 96, 90, 92, and 86, and y would have comparatively different values. Now I can create additional code over here to actually reflect the stack bar chart. I would say instead of plotting xy, plot x and y1 with the color blue. Now just to indicate that this should be at the bottom, I'll say bottom is equal to y. So to understand that, first the first semester marks will be at the bottom and the second semester marks will be at the top. Now if I run this again, I get a stacked bar chart. This has been fairly straightforward. We've actually learned how to use bar charts, stacked bar charts, and scatter plots. Let's look at a different type of a plot now. What about line charts? So line charts are one of the easiest charts to plot in Matplotlib. Now to have a line chart in place, let's again create a new dummy dataset. Over here, let's say we are trying to plot the percentage obtained by a student in 6 consecutive semesters. So over here, the x-axis will be the semesters. So let's say x is equal to np dot a range 1 to 7 separated by 1. So we'll have the values 1 to 6 coming up over here. Let's check it out. We execute x and we can see the value stored in x 1, 2, 3, 4, 5, 6. And this would represent 6 consecutive semesters. What about the y variables? Y would actually be over here the percentage obtained by him in 6 consecutive semesters. For simplicity, let's use the same function. We use the random int, random.random int, and we have, let's say, the lower cutoff as 50, the upper cutoff as 100, and we need 6 different samples. So this would give us the percentage he has scored in his respective semesters. So 67, 87, 57, 92, 93, 91. Random, but then seems very genuine, isn't it? Now let's use the plot function. So PLT is the object and we directly use the plot function and we pass x and y. Now if you look at this example, we have the line chart ready. So we can see that he scored really well in the second semester, then went down and then took off again. Finally, in the sixth semester, he closed his college on a very good note. I mean, this is hypothetical and completely random, but I'm trying to carve out a story from the random data. Again, similar to the other charts, let's add cosmetic elements over here. An overall chart title, x-axis labels, y-axis labels, and then x-axis markers. So that would be almost a similar activity. Let's create the x-axis list. X-axis list would be a list of semester 1, semester 2, semester 3, semester 4, semester 5. Now this is not the most smartest way to actually create labels. There are faster ways, but I'm just a little lazy over here. Yes, so we have 6 labels for the x-axis elements. So we have semester 1 to semester 6. We already have the y-axis values. We need the y-axis titles. Let's create them. So we say first plt.xdix and we map the list values of indices x to xlist. Similarly, we add an overall title. We would say overall college performance, and we add an appropriate y-axis label and x-axis label. That will be y label. Let's say percentage or GPA. Percentage would actually be better. And the x-axis label with semesters. Now the overall part looks good. Let's have it plotted. Looks better? Now in some cases, you would actually need markers. So rather than having a line chart, you would actually need a more visually appealing element. So what if we have markers over here? Now to add markers, all we need to do is we need to pass a third element to the plot function. So the plot function, which is right here, we add a third element. The third element over here, let's say would be blue triangles. So we say blue and triangles. And then we plot the same function. Does it look better? Oh yes. But then probably we need a red line associated with this and the markers along with that. So let's do that. So instead of just having the markers, we'll say plot x and y with blue markers, and then we'll say just a red color or any color line. Does it look good? Kind of better. What if we wanted to change this color, the line color? Let's do that. So we add another element, red, to the second plot, and now we run it overall again. And there we go. We have blue markers in triangle. We have a red line chart. We have the x-axis label. We have the y-axis label. We just missed out one element over here, which is this x-axis list. And let's run it again. And we have the semester values, and then we have the entire plot ready. So we're saying overall college performance for John throughout 6 semesters. This is how his performance seemed to be. In the first semester, he scored around 66. He shooted up in the second semester and then drastically fell down in the third semester. But then, after a lot of hard work, he picked up and he gracefully completed his college. That sounds like a fair amount of good story. Now, with this example, we've completed 3 important plots in using Matplotlib. We completed scatter plots where we study the relationship between 2 variables. It could be positively increasing, it could be negatively increasing. Second, we look into bar charts. We look into single bar charts and stack bar charts. And we try to understand the strength of similarly associated variables. Third, we look into the line charts with markers. This is where we understand the progress of an element through different states. So of an element over here would reflect marks, and through different states would reflect the different semesters during that course time. Last but not the least, we have one type of charting element left, and that would be histograms. Now, this list is definitely not exhaustive, but then let's look at one more example before we wind up this exercise. Histograms. Histograms are actually used to look into the observations frequency across different bins. So for example, let's say we have a class of 60 students, and these 60 students have scored a value of marks between 0 to 100 in a semester. Now we're trying to understand the decile distribution, that is how many students scored between 0 to 10, and how many students scored between 10 to 20, and so on. Now a histogram gives us the frequency of observations in each of these bins. It helps us to understand how well the data is spread across the deciles. Let's take a random example again. But instead of a random example, let's look into the previous example of satisfaction index which we had in the HR analytics dataset. So if you remember, while exploring pandas, we imported a dataset into DF, which was the HR analytics dataset. Now if you do a df.shape, let's look whether we have the same dataset in memory. Yes, we have approximately 15,000 rows, 10 columns, and one of those columns should be the satisfaction level. Do we have that? We do. So what we can do is, we can actually, now since we know that satisfaction level is a score between 0 to 1, we can actually create 10 bins from 0 to 1. So these 10 bins will be a representative of 0 to 0.1, 0.1 to 0.2, and so on. The last one will be 0.9 to 1.0. And we can actually see where do we have a clutter, like majority of the employees fall into which bucket. Now this can be explored using a histogram. Now using a histogram is very simple. Now we have a plot function with histograms, plt.hist. Hist gives us a very simple way to plot a histogram. I'll just take a minute over here to walk you through the syntax. It will ask you for the x values, number of bins, and range. You can ignore most of them, and what you can do is you just pass in the x values. X values over here would be df and satisfaction level. Now this would be a series of approximately 15,000 values, and we say bins is equal to 10. Let's try and execute this. Yes, We see 10 different bins, 0 to 0 0.1, zero point 0.1 to 0.2, and so on till 1.2. These are 10 bars separated together. And if you look over here, we can see that maximum employees fall into this bucket, that is 0.7 to 0.8. There are a couple of employees who had almost zero satisfaction level. That numbers are pretty high, which means these are probably frustrated employees. And then relatively low number of employees between 0.2 to 0.4, and the numbers shoot up. Now this is how we study the overall distribution across different deciles using a simple bar chart, simple histogram. Now, like the earlier visual plots, we can also have cosmetic elements over here. And these would be as simple as the title, the x-axis label, the y-axis label. Let's say we have, my apologies, let's again copy them and we can just tweak it over here. So let's say overall distribution of employee performance. On the y label we have frequency of, or in fact you can just say number of employees. And in the y-x-axis we can have satisfaction level. And now we can have the chart rendered once again. And we have a beautiful chart that helps us study the distribution of employee satisfaction across different levels. Intuitive, isn't it? So using simple plotting functions available in Matplotlib and with almost limited amount of reusable code, we have visualized a couple of different elements across random scenarios. We've leveraged line charts with markers, that is, and without markers. We've leveraged frequency charts, that is histograms. We've also looked into scatter plots, bar charts, and stacked bar charts. Now, this doesn't complete the entire story. There are several other plotting functions available under Matplotlib, and several of them are actually important. Few important can be easily called out as the pie charts, the area charts, and probably we might be using them sometime down the line. In the next module, where we will be exploring data, we might actually come across a couple of different plots which we have not covered over here. But then these four charts or plotting functions will actually give you a strong foundation to explore the remaining in a very easy and intuitive way. I hope this module has been helpful. With this, we come towards the end of module 2. Let's take a minute to recap the entire content that we have covered in module 2. So we go back to the presentation and let's traverse back to the agenda and just let's do a check. Have we covered all the elements which we planned? We started with a quick recap. Right from module 1, we understood why is Python important and how did Python evolve into the data science fraternity. We took a quick recap to understand the evolution of Python in the data science fraternity. How did it start? From 2009 onwards, how did it progress? What packages propelled the use of Python in data science? Once we had a fair amount of background, we looked into the use cases where we need to use Python 2.7 or 3.5. After contemplating a fair amount of points, we understood that Python 2.7 is legacy and Python 3.x is the future. Given that our current exercise will not have any limitations due to the package support under 3.5, we plan to go ahead with Python 3.5. We waded through a couple of simple installation steps with Anaconda distribution for Python. We looked into simple steps how we can install Python Anaconda under Windows, Macintosh, or Linux. We also looked into the Spider IDE. Once we had Python set up on a system, we started learning Python bit by bit. We explored the different data types. We explored 4 basic data types and 4 advanced data types. The 4 basic ones being string, boolean, integer, and float. The 4 advanced ones being set, tuple, dictionary, and list. We had the basic data types and advanced data types explored. We also learned about 2 important Python packages, pandas and numpy. We looked into numpy and understood how we can create 2-dimensional or 3-dimensional arrays, augment them, perform mathematical operations, trigonometric operations, and linear algebra operations. We also looked into pandas And in fact, we spent quite some time with pandas. In the entire course, we spent a significant amount of time for data manipulation and data engineering using pandas. We used different functions where you could go ahead, group by, merge, join, concat, pivot, and understand different data types. Slicing and dicing was extensively experimented in this module. Finally, we also looked into data visualization. We leveraged the Python's plotting library, matplotlib. We used 4 different plotting functions to build a strong foundation in data visualization. We understood bar charts, scatter plots, histograms, and line charts. We also mentioned and detailed a couple of other important plotting functions, which I would strongly recommend the readers to explore on their own. We missed out on one important function. We discussed about functions and how do we create custom functions and how can we leverage these functions using the apply function on a pandas data frame. All in all, we looked into the length and breadth of Python. We explored the basic fundamental concepts that will help us to move forward. Now, with this fair amount of context in Python, I'm sure the next steps for you will be fairly straightforward. In the next module, we look forward to exploratory data analysis and statistics. I hope this module has been really helpful for you. Thank you so much for your time. Looking forward to seeing you in module 3.